friends, today is the day when we are going to learn analyze phase. This analyze phase will have all the possible causes, prioritization of the causes, quality tools, as I discussed with you yesterday, Pareto and lean principles. So we all going to learn all this today. So you can check out first. Let's go through the PPT and then we will discuss through a video, or maybe vice versa, whatever you like, guys. Shall I go and play a video for you first so that you understand all the 7 tools? And then we can go through the PPT also. All right. So let's do that way. Okay, perfect. All right, guys, I'm going to play this video for you so that you have a good understanding of 7 QC tools and we can use them to solve the problem also. So please watch this and we'll discuss every topic after this.
Academy, and in today's video, I want to talk about a really important topic, which is the 7 QC tools. Now, whether you just want to get better at work and use these tools in your everyday job, or you're preparing for something like the Green Belt exam or the Black Belt exam or the CQE exam, today's lecture is for you. All right, let's hit it with the computer and get started.
All right, let's go ahead and jump in right into the agenda. So we're going to start with a brief intro of the 7 QC tools, kind of talk about all of them and how they fit into the problem-solving process or the improvement process. And then we're going to go through each one. We're going to start with the flow chart, the check sheet, the Pareto chart, the cause and effect diagram, scatter diagram, histogram, and then the control charts. And then along the way, as we go through this, we're actually going to work a problem using all 7 tools, and we're going to reduce the number of defects associated with our toaster. All right, let's go and get started. So the 7 QC tools, I love this quote from Kaoru Ishikawa, who said, as much as 95% of quality problems can be solved with 7 fundamental tools. And I absolutely agree with that. I think these tools are probably the 7 most powerful tools. Whether you're talking about green belt or black belt or quality engineering, it doesn't matter. These 7 tools are incredibly powerful for solving problems and making improvements. And this is a really important topic. By the way, as we go through this, I'll make sure to talk about where we're at in something like the Plan, Do, Check, Act or the DMAIC cycle. We're going to solve a problem with our toaster, and we'll use either the DMAIC or the Plan, Do, Check, Act process to do it. All right, let's get into it. All right, so the very first tool is the flowchart. And what a flowchart does is it's a visual tool that helps you depict the flow or the sequence of a process. This could be things like the flow of information or the flow of tasks or material or people or decisions. It doesn't matter. The reason that a flowchart is so incredibly valuable is it makes a really complex process simple, and it promotes a common understanding of a process. Anytime you get more than one person in a room to talk about a process, there's likely going to be disagreement about how the process works. And I love using this analogy. Oftentimes when we sit down to analyze a process, there's what management thinks is happening, there's what the procedure says is happening, there's what's actually happening on the production floor, and then there's what could be happening. And the beauty of a flowchart is it does just that. It gets everyone on the same page about what's actually happening. And I love this quote from Dr. Deming, who said, if you can't describe what you're doing as a process, you don't know what you're doing. And the best way to describe what you're doing is to use a flowchart. And that's why this tool is so powerful. If you're in the planning phase or the define phase, it's really good to use a flowchart, define your process, and then use that flowchart to plan out your experiment and plan out how you're going to make an improvement. So let's do just that. Let's say we're talking about our toaster and we want to make an improvement, right? And so the first thing we're going to do is we're going to start with the boundaries. We want to analyze a process, but we want to start with the boundaries first. So we're going to go from receiving a work order to completing a work order. That's the boundaries of our flowchart. Now I've got the team here because all of these activities, all of these tools are all team-based. So imagine you're sitting down with your team, and the first thing you're going to do is brainstorm all of the steps in the process, right? Talk to the experts. How does the process work? Use Post-it notes, right? Don't try to do this in some software. Use Post-it notes, write down all the activities, and then once you're done brainstorming, organize those thoughts into that logical flow, that logical sequence of activities for your process. And now that we have our process here, we're in that planning phase and we want to create a target, right? What sort of improvement are we going to make? And we want to reduce defects by 25%. Now, we can't make an improvement and we can't solve a problem without data. And we know that most of our defects happen during final testing. So now we need to collect a little bit of data, and this is where the check sheet comes into play. So the check sheet is a very simple tool for collecting, organizing, and analyzing data. every problem you solve or every improvement you make should be based on data, and the check sheet is probably the most powerful tool for collecting data. Now, there's something wrong with the check sheet that I'm showing you here on the screen, and that problem is it doesn't have any metadata. If you're collecting data and you want to make a high quality decision using that data, you also need metadata. So when you're creating your check sheet, don't forget to include things like who and when and where. All those key elements of data integrity and data accuracy are really important for making high quality decisions. Okay, so we've got the team together, and again, we did a little bit more brainstorming. We said, okay, at final testing, we have 8 defects that we want to collect some data on. So we create this check sheet, we've got our metadata here, we hand this off to the team, and they come back to us a week later with a bunch of data. Now, this is fantastic. We finally have some data that we can analyze. And the question is, which defect do we focus on? I want to improve our target. So we originally said we want to reduce defects by 25%. Well, now that we have a little bit of data, we can actually create a target. So we have 145 defects across a whole week. That's 7 days. That means we're averaging about 20 to 21 defects per day. Now, if we can reduce that by 25%, we will eliminate 5 defects per day. Now, we obviously can't focus on all these defects, so the real question is, how do we know what to focus on? And that's where the Pareto chart comes into play. So the Pareto chart is another QC tool that allows you to analyze your data in search of the Pareto principle. So what is the Pareto rule, or what is this 80-20 rule? So this is a natural phenomenon that was discovered by a guy named Vilfredo Pareto. He's an Italian researcher who was studying land ownership and wealth distribution in Italy and in Europe. And what he found is that 80% of the land was owned by 20% of the people. And this 80-20 rule and this 80-20 phenomenon was also experienced by a guy named Joseph Duran. Now, he gave credit for the tool to Vilfredo Pareto, but he was the one who popularized this idea of the 80-20 rule and this idea of the Pareto chart. And what he told us and what he taught us is that a Pareto chart helps you separate the vital few from the trivial many. Now, what did Duran mean? What he means is when you're solving a problem, there's often 1 or 2 key issues, key root causes, or key defects that you need to focus on to have a major impact on that particular situation. And that's exactly what you see here. When we take our data from the check sheet and we put it into this Pareto chart, we see that control PCB issues accounts for nearly 40% of our defects. You can see if we come across here, we've got 40% of our defects coming directly from control PCB. Now, there's 2 things happening on this graph. Obviously, there's the blue bars, which are simply just the frequency or the count of defects that occurred throughout the week. And then this black bar is actually the cumulative line. So this first defect accounts for 40%, and then we go up and up and up all the way to 100%. Now that we have this Pareto analysis and we know that control PCB is our primary issue, it tells us what to focus on. Now, we still don't understand why these issues are happening. And this is where something like the cause and effect diagram can be incredibly useful. So this is the fishbone diagram or the Ishikawa diagram. There's all sorts of different names for it, but it is a cause and effect diagram. And the way this works is we start with the effect. That's over here on the right. That's the head of the fish here in orange. This is our effect. And so step 1 of the cause and effect diagram is to start with a really well-written problem statement. So I've put in PCB failures, but in reality, you want to have a much more descriptive problem statement than this. And once you have this effect, you can start working through the fishbone process to analyze all of the potential causes and failures. Now, I'm showing here what's called the 8 M's. And this is the beauty of the fishbone process, is that it's a well-structured approach to root cause analysis. It forces you to think about all of the potential different categories or scenarios or causes that might be contributing to your problem. Now, along with the cause and effect diagram are a number of tools that you should be using. So I would recommend you get out your flowchart, look at your process, use your flowchart, and ask yourself, how might each step in the process fail and contribute to the effect that we're seeing? Teamwork is also a must here. You're not going to be a subject matter expert in all of those 8 M's, and you need people from operations and engineering and quality and R&D and marketing and maintenance to really do a thorough analysis in each of those areas to truly understand the root cause. And then, of course, brainstorming. You're going to have to creatively think about and talk about and discuss potential root causes that maybe you're not even aware of. And then the 5 why analysis. I love the 5 whys. It really helps you go from a high-level symptom down to the true root cause and really ask why, to truly get to those real root causes that you need to address. And then as you have that team discussion and you go through the process, you can identify potential root causes and contributing factors to the problem you're trying to solve. Now, obviously, again, we have to go back to that Pareto principle. We can't focus on everything. We have to talk about the most likely root causes and the most likely contributing factors. So again, at the end of your cause and effect diagram, you might identify 3 or 4 issues that you need to study further. Now, I want to talk about this one, high humidity during assembly. Now, as we were working through the cause and effect diagram process, the engineer who was helping us looked at our check sheet and noticed an interesting pattern. What they noticed here, and I've highlighted here in yellow, is that Sunday, Monday, Tuesday, we only had a few defects, right? 6 and 4 and 1. Whereas on Wednesday, Thursday, Friday, you'll notice that our defect rate jumped up a little bit. And what the engineer remembered is that we had a rainstorm come through on Tuesday night, and the humidity level in the facility really jumped up. And so what the hypothesis here is that humidity is affecting our defect rate. So I created this little table here to show the days of the week, along with the defects, and the humidity. Now, to truly understand this relationship, we have to create a scatter diagram. So here's exactly what that scatter diagram looks like. What we do here is we're plotting pairs of data. So for example, on Sunday, we had 6 defects and 18% humidity. You can see that right here. That's this data point right here. We had 6 defects, 18% humidity. Now, the way this scatter diagram works, or you might hear this called an XY scatter plot, is here on the x-axis, we put our controllable variable, our independent variable, and then on the y-axis, we put our response variable. So here we believe that relative humidity is the independent variable that is affecting our response variable, which is defects. And you can see here that there appears to be some relationship between PCB failures and humidity. Now, it's really important when you're looking at the scatter diagram not to assume that this relationship is a causal relationship, right? There's this really important concept that you can have correlation without causation. 2 parameters or 2 variables can correlate without having a cause and effect relationship. So let's assume that we've done a DOE here and we've proven that humidity has an effect on our PCB defects. We could come back to the scatter diagram. We could say, okay, our target for PCB defects is 5 or less. Let's call it 5 or less. And so we come down here to humidity and say, okay, we want to control humidity to around 20% to keep our defects low. Does that make sense? And this is a great way, a scatter diagram is a great way to understand the relationship between 2 possible variables. Now, once you've done your scatter diagram, you can quantify the relationship between those 2 variables. So what I'm showing here is the Pearson correlation coefficient. And this coefficient ranges from +1 all the way over here on the left to -1 all the way over here on the right. And that ranges from a perfectly positive correlation here. You can see that as x changes, y changes identically. And then same thing here with r equals -1. This is a perfect negative correlation. Now, as we get closer to 0, we start to lose that relationship. So an R value of 0 means there's no correlation between those 2 parameters. As x changes, y basically does whatever it wants. There's no relationship between those 2 variables. Now, the next thing we could do in our analysis is to look at relative humidity over time. So let's say we go out, we talk to our facilities engineers, we say, okay, give us the relative humidity within our environment, every 6 hours for the last 6 months, and we can take that data and we want to plot it because we need to understand how relative humidity is changing within our facility. And one of the ways you could analyze that data is with a histogram. So a histogram is just a very simple bar chart that graphs the frequency of occurrence of continuous data. And again, this is a great way to talk about your process. Every process or every product or every quality attribute out there has some level of random normal variation that will often occur in a pattern. And as engineers, we need to understand what is the pattern associated with our outputs or our process. And a histogram is a great way to understand the pattern or the variation in your process. Now, you might grab this data and you might get like a skewed distribution or maybe a bimodal distribution or an exponential distribution. There's all sorts of distributions you might get, but it's great to know how your process is behaving. Now, the other beautiful part about a histogram is you can take this data and let's overlay some specification limits, right? Now what we have is the beginnings of process capability. So the histogram is a fantastic tool to quantify and understand how your process behaves. And if you compare that against the specification limits, we can now start talking about process capability. Okay, so we're on to the very last and final QC tool. Let's assume we now control for humidity and we want to make sure that that change has been effective over time. A control chart is the right tool or the perfect tool to do that. So what is a control chart? It is essentially a tool that allows you to confirm that your process is in control. Now, when I say in control, what I mean is that you're only experiencing normal variation. When your process is experiencing normal cause variation, your data should fall within those control limits. By the way, if you're new to SPC, I have a whole separate video on control charts. You can go check it out. I've got both the X bar and R chart as well as attribute data. And a control chart is a fantastic tool to use at the end of a project to monitor and control your process and make sure that your changes were effective. And let's take a look at what this looks like for our particular process. So here's our process, right? The first week of data, you can see we're really all over the place, and our control limits are really wide because we're not controlling for humidity, and we've got all this data, and you can see on average, we have about 8 defects per day, right? And we're really jumping around here. And then let's say on day 9, we start controlling for relative humidity, and we've got our control chart, and we're collecting data, and you can see that for the next, 20 plus days, our defect rate has dramatically fallen. In fact, our new mean defects per day is around 3. So essentially, we've gone from 8 defects per day down to 3 defects per day, and we've hit our target of reducing defects by 25%. We've gone from 20 plus defects a day down to about 15, all by controlling relative humidity in our process.
Now, what we are going to talk about is some examples that we can understand with 7 quality tools. 7 quality tools are fundamental techniques widely used in quality management to identify and analyze the problems, enhance the process, and ensure product or service quality. These tools are simple to understand and apply, but highly effective. And these are my cause and effect diagram, check sheet, control chart, histogram, Pareto, scatter, and control. Now let's see one by one. Cause and effect is also called Ishikawa diagram or fishbone diagram. Now it identifies the potential causes of the problem. Cause means because of which the problem has happened, or the defect, and organizes them into categories. Helps team okay, remember this also defines the defects. It means you can talk about the problem and bifurcate it, or you can talk about the error, mistake. So cause, what is the reason behind it? So you can call it causes of the problem or defect. What is the reason for that defect? So basically we are looking for the cause of the problem. Now helps team focus on the root causes rather than symptoms. Example categories could be people, process, material, equipment, environment, because you can think around people making mistake, process making mistake, materials making mistake, equipments making mistakes, environment making mistake. So we are getting problem because of all of them or any one of them. Now, next one is my check sheet, which is a structured form for collecting the data. Basically, it is collection of the data. Collecting. I will be collecting the data. Collecting data. And used to record the frequency of events or defects. So I will use to record the frequency. Record the frequency. How many times? Enables easy visualization for patterns and trends in the data. Perfect. Control chart, a graph used to monitor a process over time. So basically, I'm using it for stability and control. Basically, I'm using this to monitor a process over time for stability. So I want to monitor if the process is stable. Identify the variation, distinguishing between common cause, which is natural variation, and special cause, which is issue needing action. So we can do some action. We can do some action on them. And then comes your histogram, which is again a bar chart showing the frequency distribution of data. Very important. How the data is going on. So how data is spread highlights the patterns like skewness, outliers. So shape, spread, shape. I can get the spread, I can get the shape, and I can also get the center of the data. Pareto, specialized bar chart. First of all, it is a bar chart that ranks causes or issues by their frequencies or impact. So it is also used for causes. It is also used for problems by their frequency so that we can categorize them or select them. And we know 80% of the problem come from 20% of the causes. So that's the way, that is the reason we are using this Pareto, and helps to prioritize action for maximum impact. Perfect. Okay, so let me, now it is better. Okay. Now scatter, very important. Only the tool which you would find most important, and that is the relationship between problem and cause. If you notice here, variable, there are two variables that we are dealing with. One is problem, another is cause. So if you want, you can write here problem and cause. Problem and cause. That is very, very, very important. Now, the relationship between variable, which could be problem and which could be cause. So helps determine if there is a correlation between variables or relationship, any relationship. Flow chart, diagram that represents a process step by step. So I want to know hua kya, what happened. So I want to know what happened. So what happened means you tell me the steps. So it provides a clear visual understanding and helps identify inefficiency area of improvement. I hope everyone understands so far. Now let's see some examples, guys. Cause and effect, which is by different causes for the problem. Identify the reason. So people oversleeping. Yeah. So basically the problem is I am running late to work, or some people are getting late to work. Running late to work, what can be the reason for running late to work from the people point of view? So the causes, if I look for people from people point of view, oversleeping, poor time management can make them late. Process, spending too much time deciding on clothes. Spending too much time deciding on clothes can make people late. Environmental factor, traffic conjunction, or unexpected weather. These are all these are all environmental factors which can impact the running, which can give you this problem. Equipment, alarm clock not set correctly can give me problem to get late. So guys, understand people, process, environment, equipment. So man, machine, material, method, measurement, mother nature. 6M you can remember, or people, process. Also, it is also good. So what are we trying here? We are trying to understand that why process can make people late, or why process can give problem, why environment can give problem, why equipment can give problem. So equipment, alarm clock is an equipment, so if it doesn't work it can give trouble. Environment is not good, so it can give trouble. Environment means traffic is unexpected weather. If it is not good, it can give me a problem. Process is not good means the you take too much time, or deciding clothes, so that can give you trouble to get late. Why people can give problem, so oversleeping or time management that they are doing, so that behavior in them can make you late. So the thing is we need to write down all cause, so which can lead which can lead this problem, and that is called cause and effect. Now if you have noticed something like this, you are going to take down in your notes, or you will start counting how many times it happened with different people. So for that you need check sheet, because you will be tracking daily expenses or daily, whatever problem. So let's talk about another problem, tracking daily expenses to manage the household budget. So you are taking the daily expenses, tracking. This tracking is check creating this tracking list is a check sheet. So you divide into groceries or dining out or transportation or entertainment logged over a month. Okay, so that way you will have at least data. And then comes your control chart, monitoring daily setup, daily step count for fitness goals. So for example, you have decided that you are going to run, so in that case you can check how many, you can monitor your progress, you can monitor your routine. Steps taken each day are recorded and plotted on a control chart. Very good, very good, very good example. If steps count drop between below a certain threshold consistently, it signals a need or to resist exercise habits. So that means you are doing something wrong, so you need to take an action. Then comes your histogram. Histogram is as you remember, it is about the distribution. So let's see. Analyzing the time spent on daily activities. Very good. Histogram shows how much time is spent on tasks like work, commuting, leisure, sleep. So for example, you're sleeping. So you some days sleep for 7 or 8 or 7.5 or 7:15 or 7:20 or 8:39. So it will, so you just write down all the duration that you had, and that duration can be mapped into a histogram, uh, which can tell you any kind of imbalance, which can tell you any kind of, how the pattern is going on. Any kind of pattern you can check, outliers you can check, spread you can check. How much spread it is. So some day 3 hours sleep, some day 9 hours sleep. So that means the spread is from 3 hours to 9 hours. So it reveals imbalances, such as too little sleep or excessive time on social media, maybe. So it will help you to reveal the imbalance. All right. And once you want to prioritize the problem, you can use the Pareto. Maybe so the problem is identifying sources of household stress. What are the different sources of household stress? And you found that uh, cluttered spaces is 50% occupying the uh, stress, you know, uh, and unpaid bills 30%, and noise is 15%, and others are 5%. So basically, you're dividing the stress into four parts with different number or different times or different percentage. So now you can put your efforts on prioritizing, on declustering, which contributes the most to the stress. So so you can find a time and make a proper routine so that you can decluster space. So every time you should have everything on place, right? And that will make you stress free. 50%. Very good. Now, scatter is a relationship between two variables. So let's say you spend time, uh, screen time, okay, spend time into screen, and does it impact my quality? Does it impact my sleep quality? So that if I want to know the relationship between sleep and screen time, I can use scatter, because one of them is problem, another one is cause, and I am looking for that cause if it has some relationship with the problem. So scatter plot shows a negative correlation. More screen time before bed results in poor sleep quality. More the time it goes into to screen, less is the quality of the sleep. Wow. So I got to know the relationship in that case. If I want to increase the sleep quality, what do I need to do? I need to decrease my I need to decrease my time to screen time. That's it. Yeah. So this insight helps establish a no screen before bed rule. Wow, that would be too tough, man. Yeah, but it's okay. Yeah, we have to, because we have to achieve something. To achieve, we have to focus on this. That we have no screen time before bed. Now, flowchart. Finally, planning. You need a plan. You need to write all the steps that you need to have. So when you plan for a vacation, so how does it go? A flowchart outlines steps. Research destination. First, you research where do you want to go, then book your accommodations, and then plan your activities, and then pack your essentials. So these are the four steps, major steps that you need to plan for a vacation. So first you research destination. Let's say I want to go to Goa, book your accommodation. So let's go by plane. So let's go by aeroplane. So we have to book tickets. Yeah, book hotel, book tickets for going from place A to B, and then we have to book the tickets. We have to book the transportations. We have to book the hotel. We have to book the anything special there which needs an advance booking, which for which you are going. You need to book all the tickets there, and then what all you gonna do. So you can plan your activities, and then pack all that you want to take from here. Yeah. Wow. Wow. That's so good, no? So visualizing the process ensures nothing is overlooked and helps avoid last minute stress. Absolutely. Majority of times we face trouble because of last minute stress. Let me take you to another part of
Do you know that PDCA is the most widely used tool for continuous improvement? And what is this PDCA? So P stands for plan, D stands for do, C stands for check. It is an iterative four-stage approach for continuously improving product, process and people. It was first introduced in year 1920 by Walter Sheward and later popularized by Edward Deming. Deming himself credited Walter Sheward as the creator of this cycle. Deming was tasked with helping Japan rebuild its economy in the 1950s so that they could compete in the world market in the future. It is also known as Deming's cycle or Sheward's cycle. It became an integral part of what is known as lean management. It involves systematically testing possible solutions, assessing the result, implementing the ones that are shown to work. Just as a circle has no end, PDCA should be repeated again and again for continuous improvement. For example, imagine that you have plenty of customer complaints about slow response rate for your support team, and you probably need to improve the way your team work in order to keep the customer satisfied. That is the point where PDCA comes into play. Deming wanted to create a way of identifying what caused a product to fail to meet the customer expectation. His solution helps business to develop hypotheses about what needs to be changed and then test these in a continuous feedback loop. There can be any number of iterations of do's and check phases as you continue to refine, retest, and trial potential solutions. When you create a new product, it is likely that it is far from perfect. Normally, we see two common use cases for PDCA. The first is the problem solving use case. Whenever something breaks down or isn't functioning as it should be, PDCA can be used as an analysis tool for uncovering the issues and coming up with a solution. The other could be the process improvement. The fact that something is working does not mean it is functioning at its best. You can use PDCA as a means of finding the potential improvements to the existing process. PDCA, that is the Plan, Do, Check, Act, is a lean tool which was originally proposed by Walter A. Sheward in his book Statistical Method from Viewpoint of Quality Control. When he proposed this model, he had only three components in his cycle, and these were specification, production, and inspection. He defined this component keeping in mind the production and the manufacturing processes that he had worked for improvement. It was used by various people and various processes since then. It was later in 1950s it took a new form in the form of a PDCS cycle. Deming introduced this PDCS cycle, and later he made a small change to it and called it PDSA, as he wanted to give more emphasis on the analysis rather than just inspection or checking. He believed that the PDCA version is not accurate because of the English definition for check means to hold back. Deming often referred PDCA as a Sheward cycle, but because of the promotion done by Deming, it came to be known as Deming's cycle. They both believe that these small changes can make a big impact to the end result. Planning phase is the first phase of PDCA cycle. The logical order begins with planning, which focuses on strategic part. You develop a project plan, which includes cost estimation, time estimation, and the resource estimation. This phase involves assessing the current process or a new process and figuring out how it can be improved. Before you make any change to the process, you need to pinpoint the exact issue you will be addressing. At this stage, you will literally create a plan what needs to be done. Depending upon the size of the project, planning can take a major part of your team's effort. The next thing is to start defining the problem statement. That is, what is currently wrong with the product or a process and how this can be improved. Here, one will try to understand what changes can be made to the process to achieve something better. If there is an explicit problem you're trying to solve, you can use something like 5 why analysis or fishbone diagram, maybe a Pareto as well, or a brainstorming technique. Next, you need to set some SMART goals. The SMART goals means it has to be specific, it has to be measurable also, it has to be attainable, relevant, and time bound. Here, you need to remember that everything should be based on hard facts rather than on speculations or assumptions. So before you move on to next stage, you need to be sure that you have answered some basic questions. What is the core problem you need to solve? What resources do you need? What resources do you currently have? What is the best solution for fixing the problem with the available resources? In what conditions the plan will be considered successful? And what are your goals for this plan? Do phase is the second phase of PDCA cycle. Now that you have defined your problem and found the root cause, it is time to brainstorm the potential solutions. At this stage, you will apply everything that has been considered during the previous plan stage. Be aware that unpredicted problems might occur at this stage. This is why, in a perfect situation, you may first want to try out incorporate your plan on a small scale pilot project. Think of two phase as a test phase. Once you have identified a potential solution, test it with a small scale pilot project. This will allow you to assess whether the proposed solution that you are making is working or not. Then you need to gather as much as data as possible to make sure that the change is effective or not. And finally, you need to standardize the process. Check phase is the third phase of PDCS cycle. This is probably the most important stage of PDCS cycle. It involves analyzing the collected data, comparing the actual results against the planned objectives, and discussing whether the further improvements are possible or not. If you want to clarify your plan, avoid recurring mistakes, and apply continuous improvement successfully, you need to pay enough attention to the check phase. Here you will need to audit your plan execution and see if your initial plan worked or not. Moreover, your team will be able to identify the problematic part of current process and eliminate them in future. But if something went wrong during this process, you need to analyze it and find the root cause of the problem. You also need to analyze the collected data and compare against the planned objectives. At this stage, you analyze your pilot project result against the planned objectives and expectations that you define in plan phase and assess whether the idea has worked or not. If it hasn't worked, you return back to plan phase. If it has worked, you are ready to go on to next phase, that is the act phase. You may decide to try out few more changes and do a repeat of do and check phase, but don't settle for anything less than a satisfactory or a best solution. Move on to act phase only when you are generally happy with the trial outcome. This phase is also sometimes referred to as a steady phase. Act phase is the fourth and the last phase of PDCS cycle. The final step is to fully implement your solution. So if you are solving for an isolated issue, congratulations, you are done here. But if you are striving for a continuous improvement, you should repeat the cycle from step 1, plan phase, to find the additional opportunities for improvement. Act phase involves acting on the feedback and the lessons that we have learned. Act it involves acting on the feedback. It also involves concern with the standardization, documenting, and sustaining the improved process. This phase is divided into two sections. One is the standardization. Here, the things that went right in the plan of action are standardized so that the problems do not repeat again. This standardization can be done in a new standard document, or it could be a modification of an existing document. Other thing, it could be the conclusion, which is where the final evaluation of team performance is made, analyzing all the results with the help of graphs like Pareto chart, check sheet, etc. Analyze what went and what did not went as per the plan, and try to record the learnings of all the project in a document. This repetitive approach will help your team find and test the best solution and improve them through the waste reduction cycle. The ISO 9001 standard is actually based on PDCA, which can be applied to all kind of processes. In all, there are around 10 clauses as per ISO 9001 standard. The first three clauses, that is the scope, normative reference, and the terms and definition, are the information clauses rather than the clauses that actually outline any kind of action or requirement. Now let us look at the PDCA as it relates to ISO 9001 by breaking down the ISO 9001 standard into the major elements and then assigning each part of PDCA process. So under the planning phase, we have four clauses, starting with clause 4, that is context, clause 5, that is leadership, clause 6, that is planning, clause 7, that is support. And under the do phase, we have one clause, that is clause 8, operations. Check phase has one clause, that is clause 9, performance evaluation. And act phase also has one clause, that is clause 10, improvement. Different tools and techniques are used in different phases of PDCS cycle. Some of the most common tools and techniques are listed below along with in which phase they are used. For example, The process flow chart is mostly used in planning phase, do phase. The cause and effect diagram in planning phase and the act phase. The Pareto analysis in the planning phase, check phase and the act phase. The brainstorming technique in all the phases. The check sheet in planning phase, check phase and act phase. Force field analysis in the do phase. Impact diagram in planning phase and do phase. Consolidation diagrams in planning phase, check phase and the act phase. Let us look at some of the benefits of using this tool. The first benefit that we have is that it is simple yet powerful way to resolve new and recurring issues in any industry, department or process. It provides a standardized method to achieve a continuous improvement that can be used by any employees in any department to resolve any new or recurring issues. Prevents wasted time implementing ineffective or inferior solutions. Fosters teamwork through brainstorming and problem solving. It is very inexpensive, overcomes obstacles internally. So these are some of the benefits.
So we're going to analyze the data and determine the root cause. So that's how we are talking. That's what we are talking about. So what do you understand by analyze? So you are going to see how things are going, right? Root cause analysis is a process for identifying the root causes of a problems and systematic approach for responding to them. Root cause analysis is based on the idea that effective management should find a way to prevent problems before they occur and after the work of an entire organization. Okay, so affect the work of an entire organization. So basically, a way to find the problems before they occur. Very good. So root cause analysis is one of the most crucial problem-solving elements in quality management. It is an important part of Six Sigma methodology as it is a key component to analyze of the analyze phase of DMAIC, define, measure, analyze, improve, control. All right, so here it is, and then we can check out. I hope everyone understand root cause analysis. Let me show you a video which can help you to understand much better. Okay.
A3 problem solving technique. So in this video, we are going to look at what is A3 and how it is used as a systematic problem solving tool. We'll look at its origin, its history, why A3, why not A4 or A5, and what is the linkage between A3 and PDCA. We'll also look at the different stages of A3 problem solving technique. And finally, we also look at how the A3 format looks like and how do you fill this A3 format. So what is this A3 report? So before understanding this A3 report and how to fill it, let us understand this concept of A3 problem solving technique. So A3 is basically a problem solving methodology that was created in Japan by Toyota as a part of Toyota production system. It is associated with lean manufacturing and is used for continuous improvement efforts at many workplaces. In short, it provides a simple and a logical way to solve a problem and then communicate the same information about the problem to the other co-workers. A3 problem solving can be nicely mapped with different phases of PDCA, that is a plan, do, check and act. So what's the story behind this A3? In the name of A3, why not A4 or A5 or A2? So the term A3 is derived from European paper size that is about the same size as an American 11-inch by 17-inch or a B size paper. Now using an A3 method, team can create a one-page improvement project report on A3. By limiting the report to one page, the team are more focused to be concise and be thoughtful about including only relevant information on the report. So this makes the report easy to digest and make it relevant to the other stakeholders. A3 format is typically used by Toyota as a template for three different types of report: problem solving, project status report, and proposals. In this video, we have focused on the problem solving report simply because it is most basic style and making it the best starting point for our tutorial. So how does A3 problem solving methodology map with different phases of PDCS cycle? For this, first we need to look at all the stages of A3 problem solving methodology and all the steps that are involved. The first step that is involved here is background and identifying the problem or a need. That is, we need to select an issue that you want to resolve first. Probably state how this issue impact your business, your customer, your process, and of course your bottom line. Next, the team should break down or further define the problem. You can ask relevant questions using the 5W1H technique, that is what, when, where, who, why, and how. Next step is to understand the current situation of the problem under consideration. So the problem can only be addressed by understanding the current situation with the help of visual depictions. Toyota indicates that it is important to determine the extent of the problem. Next step is to develop a goal statement, a SMART goal statement. The goal should be specific, measurable, realistic, achievable, and timely bound. You can map out what exact goals you want to accomplish. Then you need to perform a root cause analysis. Now, conducting a thorough analysis as to what might be causing this particular issue or a problem. By finding out what causes the problem, you can take some measures against that. The main cause can be identified by any of the root cause techniques like fishbone or 5i. So once you have identified the root cause, now it is time to take some countermeasures. The underlying cause can be properly addressed by using these countermeasures. These are the steps that you are going to take to make necessary changes. By making sure that you are addressing the root cause you have found and not the symptom. Next is the implementation phase. This is your well thought out workable plan. Includes a list of actions that needs to be done so that the countermeasures can be take place and improvement can be obtained. Then we have this follow-up plan. So the follow-up plan will check whether the changes and the adjustment will actually yield the best results or not. So this is to make sure that the target goal was met.